You look at just 1A.
Yeah, let's see.
All right, so here's this case where you have a triangle inscribed within a circle. And the only information provided is that the sides of this inscribed triangle are 12. All right, so if you know that these sides are 12, okay, what that tells you then is if we took this triangle right here and we divided it, so since it's an equilateral triangle, when we draw our altitudes, once we draw two altitudes, this point of intersection is all those points of concurrency. Okay? And so what we can do is we can use that to help us find the total area. So our shaded area here is given by taking the circle minus the triangle. Okay? So the circle formula is pi r squared, triangle formula 1/2 base times height. Okay? So what we need to do is we need to figure out what is our radius. And then we can also say the base and height of our triangle. Well, the base was given. The sides of the triangle were 12. So all we need to do is figure out what our height is. Okay, so when we create this little 30, 60, 90 triangle in here, if this hypotenuse is 12, that means that this side opposite the 30-degree angle is half of that, or 6. And it means that this height is going to be 6 times root 3. This is our pattern, right? X, 2x, x root 3. So we can just use that pattern, plug in our height, 6 root 3 for the triangle. So we have that portion. All we're left with is the radius. And because this point of concurrency is also the circumcenter, it means it's the center of the circle that surrounds the triangle. This right here is going to be the radius of that. And going back to the fact that this median is cut off by a centroid in a ratio of 2 to 1, this upper portion is what fraction of the whole thing? 2/3. So if we just take 2/3 of 6 root 3, that's going to be this upper portion here. So 3 goes into 6 twice. So this is going to be 4 root 3, and that would be our radius. So then it's just a matter of calculating this number.